and common sense. So let's jump into the question now. All right. So look at this question. It says that Grace has some books. She received 7 more books and now has 25 books. Which number sentence best represents this information? Now, this is the easiest way that I have seen them express this question. All right. So now the first assumption that they have to make was that the number that they're looking for is box. That's just all. They could have used a symbol. The box is just the easiest thing to start with. They could use anything. So now, once they make that assumption, what did they do? All right. So the first step was that they assumed that the number of books that Grace has is what? Box. Now remember that is a specific number. That's why they have to do that. All right. So the second step is that remember that you can add box and subtract box or pretend to do it. You can't really add this, but you can pretend to do it in order to figure out boxes. All right. Now, by applying simple mathematical technique, you can be able to figure out what the box is. Now, what they did here now is that in this question, you're not expected to know what the box is, but I just decided to use this to illustrate how you can figure out what the box is. So using mathematical technique. All right. You could use common sense by just saying which number would you add to 7 to get 25. Okay, that's just common sense, and which is also logical reasoning. But this now that will be useful to a certain point. But solving with this mathematical technique will allow you to understand algebra in coming future, which is the foundation of advanced mathematics and computing. So you have the box, and now you have plus, and then you have 25. Now remember, if we apply the equality principle and remove this 7 here, in order to do that, we would have to what? Remove 7 from the other side of the equation. If we apply the equality principle, then we will need to remove the 7 over here. And if we do that, we have to remove 7 from the other side of the equation in order not to violate the rule of equality that we stated up here. But now the next question is, how do you remove that 7? The only number that can neutralize 7 is 7 itself. All right. But because the 7 is only added to box, it means that the only way to neutralize that addition is a subtraction. So that's the reason why we have to say a negative, which is a minus, which is minus 7 to subtract from 7 to neutralize it. And when you neutralize it, this will turn to be 0. And so you have the box left alone in this side of the equation. And that is the goal. When you're solving for an unknown or a box, something you don't know but you wish to know, the goal is to leave the box or isolate the box alone. That is stay alone in this particular spot or in the in one side of the equation, either the left or the right. Most persons like to leave it on the left. All right. So that whatever is on the right, whether or not it's a number or a list of numbers, would be equal to that box. And once that they are the same, no rule has been broken, and therefore whatever is on the right side would be the answer as what is on the left side, because they are the same. If they're the same, you can go with it. You can travel with that to anywhere because it's the same, and you can exchange them. So that is how you use the box to solve problems. All right. So let's see other examples. So the next example is question 7. For question 7, I think I had gone. So this is a solution, but I'm going to wipe this out and go over it from the beginning. So if you could solve this, you could skip to the next part where I explain the question from the next year, which is probably 2019. So I'll wipe this and clean it and go over this again. So let's see how I would use the same rules. I would squeeze the words out, use the numbers alone to work out the problem. So remember, that's the aim. The aim is squeeze the word out, remove all the words, just work with the numbers. All right. But again, and let me just take a pause here. The way Cpea is organized is like this. The first 6 questions is usually like you have seen, right? Number theory, where they talk about the place value, they talk about prime numbers, HCF and all that, and LCM. Number theory. And then from the 8 to like the 15, you now have worded problems that will be on algebra and running around things like what you've just seen here. So it's like 4 sections. So the second section is going to be worded problems, and between the second section and the third section, you would have a mixture of percentages, fractions, and then fractions, and you would have a mixture of percentages, fractions, and and then currencies. Yeah. And then in the third section, you will now have 2D shapes, time, and some other, assorted issues. Then on the last section, you will have things like from statistics, mean, pie chart, pictograph, oh, they love pictograph, and other things that I might join in the mix. So it's usually in this section, all right? So most persons struggle with the second section, and sometimes it might set the tone for the exam. So you want to really, really focus on the second section and make sure that you get it out of the way. All right. So I think my time is going to, so I'm going to stop this video here and continue it again in the next. Oh, I have 8 minutes. I should be able to explain question 7 in 8 minutes. So question 7 asks that K has 10 beads. She plans to make 6 necklaces. Each necklace is made using 30 beads. How many more beads does K need? All right. So let's get out the numbers and stick with those numbers. So the most important thing I want to write here is the fact that K has 100 beads. All right. So the first sentences would usually be like the facts. First and second will be a fact, or maybe sometimes relationship between the fact and the second and third will tell you how those facts relate to each other. So just watch out for those and take your time step by step. It's very systematic. So the second sentence says she plans to make 6 necklaces. All right. So she wants to make a total of 6 necklaces, and each necklace is made using 30 beads. Now this is the way you translate this. You would say each, which is 1, each means 1 necklace is made using 30 beads. It means that the 30 beads is equal to 1 necklace because it's made using 30 beads, right? Therefore 1 would be equal to 30 beads. This is actually a very important relationship. All right. So they've created a relationship between the necklace and the beads, and this is what you're looking for. All right. This is a simple way to express it. So now, how many more beads does she need? All right. So she wants to make a total of 6 necklaces, and 1 necklace could be made using 30 beads. Then what this means is that in order for her to make 6 necklaces, she will need 30 beads into 6 places. 1 set of 30 beads, another set, until she can have six of them. And the easiest way to express this is to say 6 will be equal to box. Again, we could use this box system or use the common sense system to say that, all you just have to do is to say 6 times 30 to work it out. Well, because we do not know, we could say it's equal to box, and now we what? We cross. This technique is useful in working these problems whenever you are confused. But if you know the solution, you can skip to the relevant parts. Times 6 necklace. So n represent necklaces. I'll write it in full now. Again, we want to leave the box or isolate the box in this one side. In order to do that now, I'll have to introduce another technique. You see, in the previous one, we had the 7 the 7 was attached. The relationship between box and 7 was an addition sign. But here now the relationship is a multiplication. We cannot do addition. Because if we try to do that, that will cause a problem. So what we will do is use the opposite of this sign, because it appears to us that in order to have neutralized 7, we use the opposite of addition. So now we can use the opposite of this multiplication, this sign here. And the opposite of multiplication is division. So if we say divided by n necklaces, that will cancel both the necklace and the 1, and this will be left alone. And we can do the same thing here, and what? Divide by what? 1 necklace as well, which is 1n. And that will cancel this necklace, and what? 1 cancels 6, we keep 6. And then we have the box will be equal to 30 times 6. This is an important technique that could be used to solve even more complex problems. 30 times 6 will be the same thing as 180 beads. And that does it for us. So it means that the unknown, which is the box, is equivalent to 180 beads. And that's what we would, need to make 6 necklaces. But look, she already has 100 beads. So this is the reason why you have to read the question, because if you notice the answer 180 is there, but it is not the right answer, because you ask how many more beads will she need, because they want you to remember that she already has 100. So what she needs now what she needs now would be equal to 180 minus the 100. Why? She already has 100, so she only needs what? 80 more. And that solves the problem, 80 more beads. So that's how you solve this problem. So this is actually easy. As the year go by, it becomes a little bit more interesting. So let's see how it is, how this problem was actually expressed in the next year.